Push that rock here with Simpson Math. Let's talk washer method for computing volumes and solids of revolution. So in the last video we had a generatrix that we rotated about an axis of revolution using the x-axis. It could be the y-axis or it could be any line really. But we rotated some function f of x about the x-axis and we created a solid of revolution and we learned how to compute the volume of that. In this video we're going to have a pair of generatrixes. I don't know what the plural of generatrix is, but we'll have a f of x and we'll have a g of x, and we're going to rotate them about, and the solid that we're creating is created by this area betwixt the two curves. So this area is rotating about 360 degrees about this x-axis. So here's when it gets here, then we have the area only 180 degrees of the revolution, and then it's got to go under my paper and rotate back to here, and that will create a solid of revolution. And obviously something's a little different here because this area under g of x is left out, and that's exactly what you do. You leave the area under g of x out. So let's picture our disks that were in f of x. So every cross section of the solid will have this circle. If it were the full solid of all the area under f of x, it would have, these circles everywhere. And we would find the area of every circle in all infinite many slices using a limit process, which integrals are limits. Limits of Riemann sums, remember. And then we'd add them all up. That's what integration does. And we'd have the volume. But we see that we need to take out this area here. Well, there's these disks that are in here, Every one of the g of x, the area under the g of x also has disks. So all we'll do is take away this area from the total area included in this disk. So there's a little disk inside the bigger disk. So, we're going to have pi times the radius squared for this bigger disk, which is f of x. Depending on where you are in the domain, starting from a to b, you'll be at any x value, and the radius will be determined at any x value by the function f of x. And so there's the area of that curve. But we need to take away this area, so we're going to subtract off pi times g of x squared, because the radius of this little disk is given by g of x. And now we'll do a little, factoring magic. So clearly we have a common factor of pi, and we have f of x squared minus g of x squared. Now notice f of x has to be, I should have said that f of x is greater than or equal to g of x over the relevant domain, okay? So over a to b. So this being a and this being b over here. The typical, this being the lower limit and upper limit of integration. So I factor out the pi, and I have f of x being squared minus g of x being squared. And we're going to integrate that, and we can kick the pi out from a to b with respect to x, and that will give us the volume of the solid of revolution. And this is called the washer method, after those little things that you put between a bolt and whatever you're bolting in order to, I don't know what those things are for actually. I won't even pretend. I think it's to protect the thing you're bolting to do less damage and maybe to give it grip. But they look like this and they're called washers. Maybe you kids don't know what those are. But anyway, it's called the washer method because there's a little, Google it, object that looks like this called a washer. And look, every one of the cross sections will have a little washer in it. Math made simple. Simpson Math.